Hello viewers, welcome back to our YouTube channel, and today we want to continue with our series of quantitative techniques. In the previous video we looked at the introductory part of chapter 7, that was measure of variability or the measure of dispersion. And today we want to look at, of course we went ahead and we looked at one of the tools, that was the range. We saw the range, we looked at the coefficient of range and did some small computation about it. So today we want to start, of course today is 23rd July 2026. We want to start by looking at the quartile deviation. Quartile deviation. And of course we know that quartile deviation is one of the other methods of dispersion, and if you don't call it quartile deviation, you can call it semi-interquartile range. Semi-interquartile range. Semi-interquartile range. You don't call it the quartile deviation, you call it the semi-interquartile range. And of course we understood that the quartile deviations, these are they are positional and absolute measures of dispersion. So, and we said that positional, it means we cut out the arrangement and then we look at the position of that. Sometimes they may call them the semi-quartile range or semi-interquartile range, but whichever aspect, just know that the quartile deviation tells us how spread the data is of the middle point of the data set. In other words, we try to look at, we divide this data into two. We look at how the data is spread on at 50%. So we try to, it tells us how spread out the middle 50% of the data set is. So it focuses on, it tells us, let me write it, it tells us how spread out the middle 50%, the middle 50% of the data set is. In other words, it tries to tell us how the data is going to be spread as long as we are looking at the half of the data, because 50% is actually half of the data set. So we look at the data set and we tell how that 50% of the data set is spread out. So when we are looking at the quartile deviation, it always tells us that the extreme values will not be affected by the outliers, because if they are looking at the middle point, it's like we are focusing on the median. If they are looking at the middle point, all the items that are going to be in the middle, we try to look at the kind of data that is going to be on an equal side of the data set. So we will find that this kind of arrangement is not going to affect the outliers, both the extreme values on which the lower extreme value and then the highest extreme value, or the highest value among the if the outliers are being given to us. So this kind of arrangement will not get us there. So we want now to look at the formula. Quartile deviation, we get it from having the interquartile range, and then we divide this by 2. Interquartile range divided by 2, or half of the interquartile range, or 50% of the interquartile range, where the interquartile range is equal to Q3 minus Q1, where the Q3 is equivalent to the upper quartile, and then the Q1 is the lower quartile. The Q1 is actually representing the lower quartile. Now, we have seen that from the quartile deviation, we get the interquartile range, and then from the interquartile range, we divide that by 2. And of course, all this takes us to the final formula for the quartile deviation to be Q3 minus Q1 divided by 2. That is the implication. That is the semi-interquartile range, or the quartile deviation. Of course, we have now seen that we have come across some different terminologies that we need to understand what they mean, and then we can be able to move forward. We have seen that whenever we are talking about these quartiles, we have different types of quartiles. We have the first quartile, which is the true one, or what we call the lower quartile. In other words, we try to look at a distribution, then we divide that distribution into four equal quarters. So we get the data set and then we divide it by 4, whereby the first the 1 will represent the first quarter, then 2 will represent the second quartile, then 3 will represent the third quartile, and then the fourth one will be, of course, the fourth one will be 4 out of 4, which means it will be a 1. So we always get 3 quartiles. We have the first quartile, the second quartile, and then the third quartile. But it comes from the idea of dividing the data set into quarters. Maybe you can try to illustrate it and we see how it looks like. So we have, let's look at a certain graph. We can see that if we have a distribution that is shaped like, let's say it is shaped like that. Of course, here we have the frequencies. Then here we have the data, depending on what they have given us. So this will be, let's assume that this is our first slice on the data. This is now the second in the middle, then the third this side. So this will be our Q1, Q2, and then Q3. Now this will be area A, we can call it A1, A2, A3, and then A4. You can see that we have divided this data set into 4 equal parts, which means that A1 is equal to A2 is equal to A3, and at the same time is equal to A4, because these are quarters. Now the first one, which is the Q1, represents the first quartile. It represents the first quartile. Then Q2 represents the second quartile, and then Q3 is representing the third quartile. Now, of course, you can see that each of these sections will be representing a given value. So when you look at this data set that we have illustrated, you can see that we have the different letters Q1, Q2, and then Q3. Those are the quartiles. And of course, the quartiles of the data are going to be represented. If we are to draw that same graph that we have drawn up there realistically, we would get n plus 1 divide by 4, because there are 4 there are 4 quartiles, and then we multiply this by the choose like the chu value, where this chu will be the desired quartile, where n is actually the number of observations that are given to you, especially for ungrouped data set. Number of observations. Now, if I'm interested in getting the Q1, it will be 1 over 4 times, of course, times n plus 1. If I'm interested in getting the desired quartile, maybe I need a second quartile, it will be 2 out of 4 times n plus 1. But remember, we said that will always be a positional item. It's a position value. In other words, we say that quartiles are positional and absolute. So we shall get a value, whichever that we compute from here, it will give us the position where we are supposed to pick the value. If it is if I need the 4th quartile, it will be the 3rd quartile, it will be 3 out of 4 times n plus 1. So that's what we have as far as getting those quartiles are concerned. So I want us maybe to elaborate more on the aspect of the lower quartile, upper quartile, then specifically those two, because the middle quartile, that one is more like is more of the median, but we need the Q1 and then the Q3, because those are the ones that we use in the formula for computing the those are the ones that we need in the formula for computing the quartile deviation. So the first quartile, that is Q1, can call it first quartile or lower quartile. Either way, you will be right. Now, the first quartile, this is the first 25%. This is the first 25% of the data set. The 25% of the data set. Because if you get 100 divided by 4, you will be getting 25, 25, 25, and then 25. So this one, it will be 1 over 4. This 25. This one, everyone will, each of these will be 1 over 4, 1 over 4. Meaning this one in the middle will be 1 over 4 plus 1 over 4, which will be 2 over 4. Then this one will be 1 over 4 plus 1 over 4 plus 1 over 4, that is 3 over 4. You just add the numerator The denominator, you just leave it. Now this one will be 4 out of 4, which is a 1. So it is the first 25% of the data set. So at most 25% of the data set is actually smaller than the true one. 25% of the data set is actually smaller than the true one. So it divides the lower half of the data set into half. Remember, we are taking the data and we are dividing it in the middle. When you divide it in the middle, we get how the data is going to be spread on those different halves. So the first half, the first half is going to be divided into another half. It will give you a quarter, because if you have a half and you divide it by 2, you get a quarter. It's the same thing like saying 1 over 2 divided by 2. It gives you 1 over 4. So since this is a positional item, it means that the data that we are going to get is just going to help us to locate the values. But of course, if we are dealing with ungrouped data set, we know that it is very easy. We just arrange the data into an ascending order. Then we start from the smallest to the highest. Then we can be able to divide those data sets into those equal items. But from here, we can just use the formula. We just get the lower half of the data set you get a half of the other half. So that gives you the position of the true one. So you'll find that actually your true one is going to be 1 over 4 into n plus 1. This is anything number. This true one will actually be giving you a position where that number is located in the data set. So if you are to determine the true one, the first thing that you do, you first count the number of observations. If you have been given observations, maybe there are 10, you count and you find that there are 10. That's our n. The second step, especially for ungrouped data set, you go ahead to arrange the data set in ascending order. Once you have arranged the data set in ascending order, the third step is to compute, to put the n into this formula, and then you'll be able, of course, when you put the n into this formula, you'll be able to get, if it is 10, then it will be 11 over 4, and whatever you get, it will be the position where that value lies. Then you check, it will be, if this one maybe gives you, because if it's 11 divided by 4, it will be like 3 point something. It is 2.75. So it means that it is the value is going to be in between the second value and then the third value. It is in between there. So you get those two values, you add them, and then you divide. We are going to have a look at some numbers so that we can be able to see exactly what we are talking about. So the Q1, we said the formula will be Q1 will be equivalent to 1 over 4 into n plus 1. This will give you nth number. It will be a number. Then we look at now the second quartile. The second quartile. Of course, now the second quartile looks at this is the Q2. The Q2, it looks at the median, because it is the median that divides the data set into what you call a half. Median divides the data into half. So it means that 50% of the data set of the data values, 50% of the data values fall below the median. That is the implication, that 50% of the data set falls below the median. That's why we said it is a less than, we get what we call less than cumulative frequency if you are dealing with the grouped data set. That is the reason, because we're trying to look at the data that are less. But when we are estimating, we try to estimate, we can estimate that those values that are even more. So this Q3, the Q2 will be equivalent to, of course, this is 2 out of 4, n plus 1. And of course, this is just the a half, or it is 1 over 2 times n plus 1. What I'm more interested in is the second one, the third quartile. The third quartile. Third quartile. You can call it the third quartile or the upper quartile. That is the Q3. Now, this third quartile or Q3, it means that they are actually 25%. It means that they are actually 25%. 25% of the data lying lying between the median and this median is the Q2, between the median and the 75% and the 75% and the 75% cut point of the data. So it shows that we have 25% of the data set are actually larger than the Q3. 25% of the data set is larger than the Q3, because what is left from 100 minus 75, it gives you 25. So it means that 25% of the data set is above Q3. Remember, these are position. So the Q3, or the upper quartile, it divides the upper half of the data set. Remember, the Q1 was dividing the lower half. Now this one is dividing the upper half of the data set into a half. So meaning that this is actually the third quartile. I hope you are getting the argument. The whole idea is that Q1 is actually the median of the first half of the ordered observations. That is the implication. That if I have a given data set, and I divide it by 2, I divide it into half. The first half, that is the lower half, then the second half, which is the upper half. Now, if I get that half and I again divide it into a half, I get 2 halves. But these 2 halves, they have come out of the first half that we created. That is the implication, that the Q1 is actually the median of the first half of the data set when the data has been arranged in an ascending order. Then the Q3 is the median of the second half of the ordered observations. So this Q3 looks at 3/4 times n plus 1. These are position, nth number. The answer you get here is not the real answer. What you get here gives you the position where the answer lies. So we can maybe emphasize this, that we can put a note that Q1 is the median of the first half of the ordered observations. These observations have to be ordered. Then Q3 is the median of the second half of the ordered observations. These observations have to be ordered in ascending order. That we start from the smallest, then we end with the largest. So let's just have a small illustration. But before we look at the illustration, one last thing that we also have under quartile deviation, we also have what we call quartile coefficient. Quartile coefficient of dispersion. This is quartile coefficient. So maybe we will also look at the quartile coefficient, and then we get its formula as well. Then before we do the computation. So let's look at we've said there is something that we call the quartile coefficient of dispersion. Now the quartile coefficient of dispersion is equal to Q3 minus Q1 over the median times 100. It's a percentage. So with that in mind, I want us to look at a simulation and see what we can do. Of course, let's look at example, but this is for ungrouped data set. We can maybe just have a quick one just to help us. I want us, we do two numbers. Let me say students who sat for an aptitude test in a certain organization scored the following marks. The marks are 30, 38, 50, 22, 40, 25, and then 60. Then the required is to find the value of the part A, quartile deviation, then part B, the quartile coefficient. So we said the steps are very easy. First, arrange the data set in an ascending order. So you rearrange the data that was given to you from the smallest to the largest. The second thing that you do, you start getting the position of those quartiles. You compute the positions. Of course, there are very many methods. Of course, in high school, we used to just, as long as you arrange the data set, you divide those values into half. If they are not even values, then you are going to, if they are even, then you just get the two numbers and then you divide, you get that first median. Then you also divide the rest of the values. But here, let's use the formula. The reason why some of those methods still work even up to now is that most of the times these are estimates, these computations, even if you use the formula, this gives you a rough figure for you to make a decision, especially if you are dealing with grouped class frequency data set or distributions. So let's look at the solution. Of course, the first step is to rearrange the data set. So if you look at the data, the smallest value is 22, 25, 30, 38, 40, 50, and then 60. There are 7 values. So our n is equal to 7. There are 7. So the position of Q1 will be n plus 1 over 4, fourth number, meaning it will be 7 plus 1 over 2. That gives you 8 over 2, that's a 4. Fourth position. So we count. This is now the first, second, third, and fourth. No, this was dividing by 4. Sorry for that. This was dividing by 4. It gives you 2. This is a 2 because here we are dividing by 4 and we count 2 positions, 1, 2. So the Q1 is actually 25. Then we get the position of Q3. Position of Q3, it will be equaling to 3 over 4 times n plus 1th number, and this will be 3 over 4 into 7 plus 1. Of course, 7 plus 1, that's 8. 8 times 3, then divide by 4. That gives you sixth number. And the 6th number means the Q3 is actually equaling to the 6th number. You count, these are 2, 3, 4, 5, 6. It's a 50. So the Q3 is actually 50. Because 8 times 3, we got 20. 24 divided by 4, that gives you 6. And the 6th number is 50. So even if you want to divide this into the other, you start cancelling. You cancel this and this, this and this, this and this. You will see that the middle point, this is the middle point. Now the second half will be here. The second half, in the second half, we will have it here. Then this one will be here. If you have taken this one as your median, this is Q2, then this is Q3, and then finally this is Q1. That is if you are dividing, but it's better to go with the formula. So then our quartile deviation will be the Q3 minus the Q1 over 2, and our Q3 was 50 minus 25 divided by 2, and that gives us a 12.5. These were marks because they told us these were students that performed like that in their aptitude tests. So part B, they wanted us to get the quartile coefficient of dispersion. And we say the quartile coefficient of dispersion is Q3 minus Q1 over median times 100. In other words, or you can say it is Q3 minus Q1 over Q2, because the Q2 is the mean. So the Q3 was 50 minus 25 over, this is times 100. Now the median, of course, it is their half, 1 over 2. It is the fourth number, which was 38. So 50 minus 25 divided by 38 times 100. The median, we said that is the number that is in the middle. Of course, that gives you, the answer is 65.79%. That's the answer. Now, one thing that you need to understand is that they may ask you to interpret, because remember we say these are just positions. If they tell you to interpret your results, what are you going to say? Of course, there are those where we get the interquartile range. You can just also maybe compute that. Now, how are you going to interpret the data set if they tell you to interpret the data? If they tell you to interpret the data, the implication is that you look at the first quartile. Because we got the first quartile, the Q1 as 25. It means that 25% of the members or of the students who went for the aptitude test, they got lower than 25 marks, because our first quartile, or the Q1, was 25. So we say that 25% of the students scored below, they scored below 25. Remember now, 25% of the students, these students are 7. There were 7 students. So 25% of those students scored less than 25. Now for the second quartile, remember this is our item that is in the other quarter. You can say the easiest way to interpret the upper quartile is that you say 25% of the students scored above 50 marks. because our upper quartile was 50, meaning that we had 25% of the students scoring above 50. Or you can say 25% of the students, or you can say maybe 75% of the students scored less than 50 marks. So either way you will be right. The other person can also say that 25% of the students scored between 38 and 50, because 38 was the median. So the 25% scored between 38 and 50. Because from the lower quartile to the median, there is 25%, or there is 1/4. I hope you can know how to interpret this kind of data. It's not a matter of us discussing and understanding what we have computed, but analyzing the data is what is more important. Now, I want us to look at what we call decile. I never wanted us to look at the decile, but I'm just going to explain deciles and percentiles. These ones we are not going to compute them, percentile, but I'm just going to explain percentiles. But I want to start with deciles. Now, for deciles, if you order the data like the way we have ordered, you rearrange the data in an ascending order. And now what you are going to do, we divide that kind of data set in more than 10 times. It means the values that they are going to give you, they have to be more than 10. So we can have a graph like this. This will have frequency 0, then here we have the data. Now we are drawing this. You have to be very careful. Ask yourself why whenever we draw something like a cone or a bell shaped. You will have to understand from the normal distribution. The moment you see me drawing some of these things, don't take them for granted, because we are going to find them the other side. We find that in the middle, we shall have the D5, decile, D5. I'm not going to draw all because they can't fit here. D5, meaning this side we have 5 items. On the right, we have 5 items, and then on this side we also have 5 items. Then we start now putting in those 5 items. If at all we can manage 1, 2, 3, 4, 5 here. Even this side 1, 2, 3, 4, 5. Now the implication is that we are dividing each of these items. Now this one will be A1, this is A2, A3, A4, A5. These data sets were many, so we put the whole of this A5. This is A6, A7, A8, A9, then A10. It means that we have divided this data set into what you call 10 cutoffs. And each of these cutoffs, the cut points are the ones that we call the deciles. These cut points, this is these ones, they are the ones that we call the the decile. We will have the first decile, second decile, until we reach the 10th decile. And all these regions are equal. A1 is equal to A2 is equal to A2, and it's also equal to A10. All of them are equal. So we do the same thing as long as we have been given. We do the same thing like we did for quartiles. We arrange the data set. Then once we have arranged for the data set, we just get the what? We just get the value. If we are picking for maybe for a 6, it will be 6 out of 10 times n. If you are being given with the times n, this will be en. But if you have been given maybe other classes, you use now the total frequency. Or you can just get out this 60. The 6 over 10 is it's the same as someone saying 60%, because we are dividing this into 10 items. So you can say 60% times the number of observations. So that will also give you the reason as why I'm putting the frequency here on the y-axis is because when we are dealing with these things, we shall get the cumulative frequency. But I've just put frequency there just to show you that what we put there is actually the individual values. But if the values are repeated, we use the frequencies for ungrouped. But for grouped, we actually use the OGIVE, and the OGIVE we put the cumulative frequency on the y-axis. So that is basically for the decile. Then the percentile. The difference is that under percentile, it is percentage, and the total percentage is always 100. So we divide the data into 100 parts. So it means under percentiles, we shall have data values that are more than 100. So that's why you find that some of these, the decile and then the percentile, you'll find them under the grouped frequency, because that's where they always give you the frequency which is a little bit high. The total frequency you can find maybe it is 50, 40, 20, 100, like that, 200, 500, depending on the data set that has been given to you. That's where you find most of the times we compute the percentile and then the deciles under the other side. But just know it is the same thing. If it is a percentage and I'm finding maybe 50%, I'll just get 50%, or if let's say you are taking maybe 60, you use the same formula for the one is for quartile. You get n plus 1 over 100. Now this time round it will be over 100. Then times p. Our p will be the value. If I'm looking for 20%, then it will be 20 out of 100 times n plus 1. Most of the times, if we are dealing with data values that doesn't have frequencies, we take this n plus 1. I will explain why we put this n plus 1. because these are positions. They give you positions, then you pick the values. But when you go to the group T frequency distributions, there we don't take n plus 1. Reason, we were not given individual values. We can't pick the absolute values. Remember, we said that these values are positional and absolute. But when you are given classes, we don't have the individual values. We don't actually know how many numbers are within the group, but we just have the data set that are arranged to us. We don't know the individual values that represent the whatever frequency they have given to you, or that repeats itself for that kind of frequency. So that's why we don't take that n plus 1, because n plus 1 will be giving you a positional item. We just take the total frequency as to be our n. So summation f will actually be our n. So that's basically what I wanted to talk about as far as the ungrouped. So those kind of percentiles, deciles, I'm not saying they can't examine. Of course, there are so many things to examine, but you have to know, because it's not all that hard to know. So let's now look at the grouped. We've been looking at the ungrouped. Let's look at the grouped data. We are still looking at quartiles, but this time around we are taking the grouped data. The same way we are understanding quartiles is the same way we shall do deciles, is the same way we shall do percentiles. That's why I'm combining all of them at once. But above all, understand how you are supposed to explain, because the examiners are tricky. They may give you maybe 1 mark or 2 just to explain the result that you have got, and you lose it, yet you have done the computation and the computation was all right, but you find yourself failing that small item. So we look at the grouped data, and of course this one we are not going to have so many wording, because at least we have looked at. So if you have a data set and you want to get the mean, the middle value, or the Q2 will actually be, of course here we are going to use different numbers. We can use letters, then these letters we explain what the letters represent. It's always good to explain the letters you have, as long as the data is grouped. We always get our quartile as n. Now we are using n over 2. N over 2 thin number. So this n, where n is equal to summation f, that is the total frequency. If it is percentile, maybe we are looking at the 10th we are looking at 10%, it will be 10 out of 100 times n, and this n is our frequency, and this gives you nth number. If they are deciles, you do the same thing. Now I'm taking a lot of time and I'm passing a little bit far away from where I should just pass, but I'm creating something. This median, we know how to get the median. We know how to get the median. The same median we computed under the measures of central tendency is the same median that we are computing here. But what is going to be different, I just want you to locate this digit here in the formula that we are going to use. This item is there, n over 2. We first get that one. The reason why we get that one first, because it is the one that is going to tell us the median class. I'm starting from Q2, not Q1, because I want us to start from the known, then we move to the unknown. Now we know that for you to compute the median, that is Q2, we know by now, we said the median is going to be the LM plus, we open bracket, n over 2. Other people use a half times n, but it is the same thing like saying n over 2 minus cumulative frequency before. You close the bracket, all of that is going to be divided by Fm times I. We said the LM, where LM is the lower class boundary of the median class. Lowest class boundary of the median class is the LM. Then n over 2, this n over 2 is what I have been explaining. Then the CFB represents the cumulative frequency before. Then Fm represents the frequency of the median class. Then our I represents the class interval or the class width. Sometimes they call them width. Our n is the total frequency. I know we already learned how to do this. So that's basically what we do if we are looking for Q2, that is the median for a group T data set. Now, if we are looking for the Q3, still we use the same formula. And what changes is only this part here is the one that changes. N over 2 becomes, if we are looking for Q3, it will be 3 over 2, 3 3 over 4 times n. So it will be 3n over 4. If we are looking for the true one, then that one will be 1 over 4, or it will be n over 4. So it depends on what the examiner has asked. And we first determine that one. And the reason why we first determine that one is because we want to get the median class. Now for this one, it will be for the lower quartile class. The lower class boundary of the quartile of the... But most of the times when the examiner is asking for this question, they always put the median. Sometimes they put the median as well. So you find yourself, you are not going to struggle with so many items. But even when they have not put it, understand that the classes are going to be different. Don't pick the median class and you think the median class is going to work when you are dealing with maybe the lower quartile. The class might be different, but the concept still the same. The same way you do is the same way you do this. So the guiding factor is that n over 2. For median, it is n over 2. For lower quartile, it's going to be 1 over 4 or n over 4. Then for upper quartile, it is going to be 3 over 4n, or 3n over 4, or 3 over 4 times n minus the cumulative frequency before over frequency of that quartile class. So it's always important for you to understand, and you put that in context. So maybe we can look at a simulation. We do maybe one number, and then we move ahead, because we have not looked at the mean deviation or looking at the standard deviation, because we want to also look at the standard deviation and then the variance. Then we say that we have completed. We have completed that. So let's look at an example. Example, this is for group T. Frequency. Can start the frequency distribution. The frequency distribution below. Frequency distribution below shows rural schools. Rural schools termly expenditures on water during a survey in central Uganda. So let's look at the table. So we have the table. The table shows the expenditure. These are amounts. These amounts, they are in thousands, of course, UGX and Ugandan currency. Then we have the frequency. Have 20 to 24. have 25 to 29, have 30 to 34, have 35 to 39, have 40 to 44, have 45 to 49, and then 50 to 54. This is 9, 17, 21, 18, 15, 9, then 11. Of course, now the required is to compute the quartiles of the water expenditure. So we are computing the Q1, Q2, and then Q3. So let's go to the solution and we try to see what we have. We do the cumulative frequency table. Of course, we needed to indicate these classes they have given to us. We put the frequency, we get the cumulative frequency, and lastly, the class boundary. You only put what you are going to use. Now you'll find someone wasting time putting their x, the midpoint, x values, where you get 20 plus 24 divided by 2. You find someone is wasting time there. You only put what is required in the formula. So here we are just going to show the class intervals or the classes, then we show the frequency, cumulative frequency, and then the class boundary or the class limits. So one thing that we need to note is that we said for you to identify the quartile classes, you have to divide the total frequency by those different quartiles. If it is a first quartile, then you divide the total frequency by 4, or you just get 25% of that. If it is second quartile, same thing, you divide it by a half, or it will be 2 out of 4, which is the half, or you get 50% of that total frequency. Then for the third quartile, which is Q3, you get 3 out of 4 times total frequency. That's how we get the quartile classes that we are going to use. Then for us to get the class boundaries, we said we add a 0.5 on the lower class, then we less off 0.5 from the lower limit, then we add a 0.5 to the upper limit of that same class. If you don't want it to go that way of adding a 0.5, there is also another way. I told you the moment maybe you do so many numbers of this. If I just get this plus this divided by 2, I'm very sure I'll get a 24.5, because 25 plus 24 gives you 49, divided by 2, it gives you a 24.5. If I get this 29 and 30, I'll get what will come here. This and this, I get what will come here. This and this, I get what will come here. This and this here. This and this here. The other person, after getting this first one, you can just add on the what? The class interval, if at all it is the same. If I get 24.5, then I look at what is the class interval. How do we get the class interval? We said we pick, if we are picking the upper limit, we pick the upper limit. The upper limit will be 24 and 29 of the previous class and then the preceding class. 29 minus 24, that's a 5. Or we can take the lower limits of the two classes, 25 and 20. 25 minus 20, that's 5. So I'll get 24.5, which I've got here on that first one. Then I come and I add a 5. It will be 29.5. So either way, depending on how you have understood the concept. If you get it very fast, there are very many ways that you can use to be able to save time. So let's look at the solution. We said we need classes. The second thing that we need is frequency. That I'm going to call it F. The other thing we need cumulative frequency. I'm going to call it like that, to abbreviate it like that. Then I need the class boundary. Class boundary. Those are the only things that I need. So this is 20 to 24. The reason why we are including these classes is because we want to pick the median class or the quartile classes. 30, 34, 35, 39, 40, 44, 45 to 49, and then 50 to 54. So we put the frequency. This is 9, this is 17, this is 21, this is 18, this is 15, this is 9, this is 11. So we get the cumulative frequency. We take the 9 plus 17, that will give you 26. 26 plus 21, it gives you 47. 47 plus 18, that is 65. 65 plus 15, that's 80. 80 plus 9, that's 89. 89 plus 11, that's 100. It means our total frequency is 100. So we get the classes. This is 19.5 because we have gotten 20 minus 0.5. We go to 24 plus 0.5, that is 24.5. So this is 29 plus 5, 29 plus 24.5 plus 24.5 plus 5, 29.5 plus 5. This is 34.5 plus 5, 39.5 plus 5, that is 44.5 plus 5, 49.5, then plus 5, that is 54.5. So we just carry this one, we bring it this side, 24.5. This one we take this side, 29.5. This one here, 34.5. This one here, 39.5. This one here, 44.5. Then 49.5. And we are done. So we now we move to the quartiles. The quartiles, we said let's start we start with what we know. We start with the median, or we can start let's start with the first quartile. Of course, what I'm not going to look at is the cumulative frequency distribution, or what we call the or give. There are options where we can just plot and then we draw a graph, and that graph we start estimating. I explained that how to draw a cumulative frequency curve, and we said it's the same as an ogive. So you just compute. Actually, for if it was a graphical formula, the moment you have done this, maybe I'm just going to elaborate here. The moment you draw our frequency distribution table, then you just pick the cumulative frequency and you put it on the y-axis, then you put the upper class boundaries. You draw that 7 that I showed you. You take it to the horizontal axis, and then you start plotting. You draw that curve, you join the curve, and once you have drawn the curve, then you just get these positions. For the first quartile, you get 1/4 times the frequency. Now the total frequency was 100. 100, if you 100 divided by 4, you get 25. So you look for 25 from from the graph, from your y-axis, then you draw a line towards until it meets the curve. Once it meets the curve, you draw a dotted line moving down to the horizontal axis, and then you count those values that are there. I showed you how to do that. So you do the same for the Q2 and then the Q3, and you'll be good to go. And of course, the formulas, if you use the formula, the answers will be almost the same, unless you fail to interpret the scale if you are using the graphical formula. But even if it is less or more, it will not be so much deviating from what the formula gave you. The summation F here was summation F was 100. We pick it from here, even if we don't, but you can add up to confirm whether. Now what I want, we start with the Q1. We start with the interquartile classes. It is 1/4 times summation F or n. 1/4. So it is 100 divided by 4. That gives you 25. Now this 25 is not the answer. This 25 is a position. So it is this 25 that we shall look for under the class, under the cumulative frequency. So we pick this 25, we look for it where it is under the cumulative frequency, so that we can be able to get the lower quartile class. The lower quartile class. We get it by looking at the data set, and then we see where we have that 25. So that 25 is just a position. So we check where it falls within that table. Of course, when you check, there is no 25, we have 26. So it means it is within there. 26 is in a class of 25 to 29. 25 to 29. If you look at it here, that 26 is within the class of 25 to 29. This one, you check from the cumulative frequency, column. So we pick now the lower class boundary for that class is 24.5. 24.5. So we said it is within the class of 24 to 25. It is 29 to 25 to 29. That's the class. And we said the Q1 is equivalent to lower class boundary of the lower quartile class plus n over 4 minus the cumulative frequency before over frequency of that lower class bound of lower quartile class times the I, that is the class interval. So this was 24.5 plus, now n over 2 we got it as 25. Now what is the lower the frequency, cumulative frequency before? The cumulative frequency was in 26. We picked 26. What is before? Before there is 9. So minus 9 over, what is the frequency of that lower quartile class is 17. Then times 5. Because we identify that class interval is 5. Then when you do all your computations, you'll find that the Q1 is actually 25.44. 25.44. But remember, these were in thousands, so you multiply that answer 25.44 times 1000, and you get the answer. Then you carry out the working for the other. You make sure that you don't fail to compute the quartile class that you are computing. If you are looking at the Q2, the classes are going to be different. Q2 is the median, and this is the median class. So for the median class, we always get n over 2, meaning we are picking 50, because n over 2, that is 50% times 100, that gives you 50. So, or it will be n over 2, which is 100 over 2, that is 50. 50 is just a position. So we need to locate the class. What is that median class? So we go to the cumulative frequency table, then we look for 50. 50 is not there, but we have 65. You don't pick a number that is already less than 50. We pick 5. That's why we say that these tables, so we pick the number that is higher so that we can be able to do the interpolation. So don't ever risk to pick the number that is not higher than what you are looking for. So the number we are picking for Q, let me compute Q3. Q3 is 3 out of 4 times n, or summation f. So it is 3 out of 4 times 100. So this will give you 75. 75th position. So we look into the cumulative frequency. We look into the cumulative frequency to get the class. We don't have 75, but we have 80. So we pick a class that has that 80, which is 40 to 44. Then we substitute into the formula, And the formula, we say the lower class boundary, this is Q3. The lower class boundary, now the lower class boundary, you can see it is 39.5. 39.5 plus, this is 75, minus the cumulative frequency before, which is 65, over the frequency of that upper quartile class, which is 15, divided by 15 times 5. And once you do the computation, you'll find that you'll have a 40.17. 40.17. That's our Q3. So go ahead and compute the Q2, because we know how to compute it. I've told you it is falling under 50. So you look for 50. 50 we don't have it, we have 65. So it is, the class is 35 to 39. The lower class boundary is going to be 34.5. So you substitute in and then you compute the Q2. And that will be the conclusion of, even if they tell you to compute the quartiles, the percentile or the decile, you do the same thing. You get 10 out of maybe 100 times n. Our n is 100. Then you pick that class. It is just a matter of picking the class, then you do the other computations. And that's how we do for decile, percentile, and then the quartile. I hope we are okay with what we have seen today. And the next video, I want us to look at the mean deviation, and then we finalize the measures of dispersion. Thank you for watching.